3 of our study guide. We're finding the inverse of these functions. So remember, there were 3 steps to this. The first step was rewriting the problem with y instead of f at x. The second part was exchanging x and y, and then the third part was solving for y. So let's rewrite this as y equals 5x plus 3 divided by 7. So that didn't turn out well. Let's try that again. Y equals 5x plus 3 divided by 7. The very first thing that I want to do is to multiply both sides of, I want to switch x and y now. So x equals 5y plus 3 over 7. Now, I'd like to undo this problem on the right so that I can solve for y. So, opposite of dividing by 7 is multiplying by 7. I'm going to multiply both sides by 7. So I get 7x equals 5y plus 3 because this 7 cancels with this 7. I like fractions. Now I'm going to subtract 3 from both sides. So when I subtract 3 from both sides, I get 7x minus 3 equals 5y. Now I'm going to divide both sides by 5. So y equals 7x minus 3 divided by 5, which is an answer. Some of you are splitting this and making the 7x divided by 5 minus 3 over 5, and that is the same thing. So I want you to be really familiar with all of the notations because that's a multiple choice question. Okay? So this is the same as this, and y is the same as f at x. So be prepared for that. Okay, in question 23, we'll try that one over here. I'm going to write y equals x minus 2 cubed. And now I'm going to change x and y. So x equals y minus 2 cubed. And so to undo cubing, I'm going to cube root both sides. Now some people have been putting a plus and minus there. You don't need a plus and minus if the index is, or if your exponents are odd. You only need plus and minus for square rooting and fourth rooting and sixth rooting. So we don't need a plus and minus here, but we're going to raise each to the third power. And so this is y minus 2. And we raise that to the third cube root. Sorry, I'm going to cube root both sides. So I'm going to cube root that. So now I'm going to add 2 to both sides. Plus 2 equals y. So the inverse function of this one is the cube root of x plus 2. Now the thing to note here is that the 2 is not under the radical because we added the 2 after we cube rooted both sides. So the 2 is not under the radical. Okay, now let's try 24. I think I left enough space here for that one. 24, I'm going to write y equals the cube root of x plus 7. And notice this is very similar to 23, but it's a little different because this one is kind of in the group, and this one is in the group also, but they're going to wind up looking different. This one's outside the house, and is this one going to be outside the house or inside the house? Can you predict? So we're going to change x and y now. And I'm going to cube both sides, so this becomes x cubed equals y plus 7. And so it looks like it's not going to be part of the group, doesn't it? Because this is going to be x cubed minus 7 equals y. So the inverse function there is x cubed minus 7. Okay, next page. things that you need to really take a look at is the parent functions that we spent a little time on the board. It's kind of handy if you took a look at your study guide, all the answer choices that were correct were A. That's not going to be the way it is on the test, so just be aware of that. Did you notice that all the answer choices were A?
Yeah.
Okay. It won't be that way on the test, so just kind of be prepared for that. I was trying to give you some hints there, since this is a study guide. So this will be a multiple choice section, but this is not all of the parent graphs, so make sure that you're aware of all the parent graphs. I did try to pick the ones most missed to put on the study guide, but this one is a constant function. A constant function can be anywhere. This one turns out to be down here, but a constant function is just one that's a horizontal line. So it could be positive or negative, or even right on the line to be a constant function. So choice A is the right answer for this one. It is a constant function. In 26, hopefully you recognize this one as a cubic function. This is something to the third power. But while we have this picture, I do want to tell you that this cubic function is positive. This is x to the third. Cubic functions whose leading coefficient are positive start down and end up. Okay? So if this was a negative leading coefficient, it would look like this. It would start up and end down. So if it has a positive leading coefficient and it's an odd function, it's going to start down. If it has a negative leading coefficient and it's an odd function, it's going to start up. So we'll talk more about that, but you could always graph it. What is what?
You said it's positive, but like.
Oh, this is a standard, this is a cubic function, choice A. Is that what you're asking, what the answer to this question is? What are you asking? X to the third, the leading coefficient is positive because there's no negative sign there, right? So this one's negative because there's a leading coefficient of -1. Positive, odd functions start down and end up. Negative, odd functions start up and end down. And we'll use our calculator a lot to help us out with that too. Okay, this one is an identity function. Some of you are tempted to put constant function on this one, but this is the identity function because it is y equals x. If y equals 1, x equals 1. It identifies itself. So the identity function is the line y equals x, and that's the only one there is. So this is choice A also. So if you didn't get the A pattern, now you have it, right? Question 28. This is a quadratic function. It is something squared. Y equals x squared. It is the quadratic function. And we'll be using that one a little bit here in a moment as well. 29 is the absolute value function. And if you're having any trouble with that, I use this mnemonic device. Value has a V in it, and that makes a V. So that's how I help myself to remember that that's the absolute value function. Question 30, this one starts here and goes on forever. This is the square root function, and this is one people miss a lot too. This is the square root function. Now, a lot of you are confused by this, right? The word or phrase that best completes. It really just means answer the question. So in this case, I'm finding the zeros of the polynomial function. So as I'm finding the zeros here, the first thing that I'm going to do is plug that into my calculator. So up comes the calculator, and I'm going to turn it on. And I'm going to do y equals. So this is y equals x cubed plus x squared minus 42x. And then I'm going to graph that. And I see that it's going kind of wild. But as I'm finding the zeros of the function, maybe I want to zoom out so that I can see a little bit more of the picture. So I've zoomed down and I still see that there's 2 answers, but I might be expecting 3 because this is a cubed function. So let's see what I can get with calculate. Look at the choices there under calculate. Do you see that 2 is a 0? And so it's asking me to find the left bound and the right bound. So I'm going to move my cursor over to the left and press enter. And now I'm going to move my cursor back to the right just a little bit and press enter. And so there's a guess. So that didn't turn out the way I wanted. Okay, so what we did on this problem was we factored out an x, and then we factored this, and the 0 is when y is equal to 0. So that's why we set it equal to 0, because we want to know when it's crossing the x-axis. So if I set these pieces equal to 0, x is equal to 0, x plus 7 is equal to 0, and x minus 6 is equal to 0, and that's how I got those 3 values. X is 0, x is negative 7, and x is 6. So I factored it. There is a way to do that on the calculator. It just seems to be escaping me at the moment. So let's do number 32 the same way. Let's factor. X times x minus 6x plus 9. So this is going to factor into x times x minus 3 and x minus 3. So the zeros on this are going to be 0 and 3. So there's only 2 on this one. 0 and 3. So there's only going to be 2 places where it crosses the x-axis for this one. Now, for question 33, we do want to use the calculator piece for this one. So let's see if we can enter this into our calculator. So we have 3x squared plus 2x plus 2. And if I'm graphing that, it looks like this. And so is this going to be, I'm going to zoom 6, zoom standard, and it didn't like, there it is. So you can see that this one has a minimum and not a maximum. So we can find the minimum using second calculate, and look, it has a minimum button. Do you see number 3? So let's choose 3. I'm going to move my cursor over and press enter, and then it says right bound. I'm going to move my cursor over to the right and press enter, and it says guess. Well, I'm just going to say it's somewhere between the 2, and here is my minimum. The minimum for this is decimal. It is negative 1/3 and positive 1 2/3. So we want to find the minimum, and that is negative 1/3 and negative 1 2/3. You could write those decimals, but that's the value there. So we graphed that. Okay, so apparently I graphed the wrong equation, so let's try that one again. It is x to the 3rd power plus x squared minus 42x.
You're doing the wrong one.
Thank you. I'm doing the wrong one again. Let's try the right one. I had the right one, didn't I? It's 3x squared plus 2x plus 2. Is that the right one?
We already do.
And that's what I had graphed, wasn't it? Right? So the minimum is right here. We have to find the minimum.
We already found it.
We did. I thought I had done the wrong one, so let's do it over. Okay, so we did have the one right, except it was positive 1 2/3. So let's graph 34. You can see from this one, and this is a little bit more about what I was speaking of earlier. This is a negative coefficient. So this one is going to go like this, because it's an even function. It's going to start down and end down. So you should be able to see from looking at this graph that it's going to have a maximum, but no minimum. Okay? So we'll put this one into the calculator, and it will say something like this. Negative x squared minus 2x minus 5. Oops. Minus 5. And we're going to graph it. So this one's going to have a maximum, and the maximum is going to be in there. So I can do my trace feature again, but this time I'm going to select maximum because this one has a maximum and not a minimum. So move my cursor to the left of where that is, press enter. Move my cursor to the right of where that is, press enter. And then closer to the actual maximum, and you can see that it's negative 0.99995, negative 4. So I'm going to go ahead and call that negative 10, negative 4, for my minimum. Okay, question 30, yes. It said 0.9999995. Oh, so that's not 10, that's 1, isn't it? So it's 1.0, or just 1. I should. Maybe I already did. Graph the equation in the rectangular coordinate system. Isn't this line this? Y equals negative 5. Lots of people have trouble graphing those horizontal lines. So I wanted to give you a little practice on that. So I think, yes. I think that's all of our videos.